this video, we're going to look at a problem which combines the cosine rule and the sine rule. So in the previous two videos, we looked at the cosine rule by itself and the sine rule by itself. So if you haven't seen those, it might help to watch those first. In this video, we're going to solve a similar problem to the ones we solved in those videos, where we have a triangle with some known and unknown quantities, and we'll find the unknown ones, but we're going to use both the cosine rule and sine rule combined to do it a little quicker. So let's start by restating those rules. So both the rules apply to a general triangle. So we take a general triangle with its sides and angles labeled thusly, and we say that the cosine rule is the following. So it's three equations. They're all essentially the same equation, but because the equation applies to any three sides and an angle, and in any case they're set up like this. So you've got a given side, so in the first one it's c. When we square it, is equal to the other two sides squared and added up, so a squared plus b squared, minus 2 times the other two sides times together, so minus 2 times a times b, times the cos of the angle opposite that original side. So because here we took the side c, we're taking cos of the angle c because it's the one opposite c, and it's the same in the other two. So that's the cosine rule. And then the sine rule is just that sine a over a equals sine b over b equals sine c over c. So all these three things are equal to each other. So we're saying that the sine of an angle divided by the length of the side opposite that angle is always the same for any pair of side and opposite angle. So they're the two rules, and let's try and apply them to a problem. So the problem is, say in this triangle here that b equals 5, c equals 10, and a equals 30 degrees, and that b is an acute angle, so the angle b is less than 90 degrees. That's what acute means. Then we have to find the three unknown quantities a, b, and c. So let's start by just making clear the three that we have. These three, I'm going to leave them circled so we can see what we're trying to find. We're trying to find the angles c and b and the side a. So to look at it, maybe you can spot that the problem is we can't straight away use the sine rule. We'd always want to use the sine rule if we could over the cosine rule because it's a shorter, simpler rule. You can see the cosine rule is a long equation with squares in it. We have to square things, rearrange, take the square root. It's a bit more complicated. The sine rule is a lot shorter. The problem is, to use the sine rule, you need at least one pair of side and opposite angle to be known. And we don't have a pair like that. We know the side c, but we don't know the angle opposite it, c. We know the side b, but we don't know the angle opposite it. And we know the angle a, but we don't know the side, lowercase a, opposite it. So if we tried to plug any of the information we do have into the sine rule, you'd see that every time you try to do it, you'd have two unknowns in your equation. Because you want either the right hand side or the left hand side in the sine rule. So one of these three things, you want one of them to be a number that you know. So you can plug in, say, sine c and the side c, so that just becomes a number. But we can't do that because we don't have any of these pairs fully. So we can use the cosine rule because we do have a pair of sides and the angle in between them. And if you look at the right hand side of the cosine rule, that's all you need. You have the two sides and the angle in between them, and then using that information you can find the third side. That is exactly what we have. So we're going to find the third side that we don't have here, which is a. So we're going to use the cosine rule. So we have a solution. Start by using the cosine rule to find a, and we have that a squared is equal to b squared, which is 25, plus c squared, which is 100. So remember, b and c are given in the question, so I'm just using those quantities. And then we subtract 2 times b times c, which is b times c is 5 times 10, which is 50, times 2 is 100, so it's subtract 100 times cos of the angle opposite a, which is uppercase A, which we're told is 30 degrees, so it's cos 30 degrees. So now we try and compute the right hand side here. So we get that this is equal to, well, 25 plus 100 is 125, and then that's minus 100 times cos of 30, and cos of 30 is root 3 over 2. Either use an exact triangle to figure this out, which we've discussed in previous videos in this series, or just plug into your calculator cos 30, you get root 3 over 2. So put all this now into a calculator, 125 minus 100 times root 3 over 2, and you get 38.4. So a squared is 38.4, so we take the square root of 38.4 to get a, and that's 6.2. So we can now label on the diagram that a is 6.2, so we're going to circle a to say we've also found that. We just need to find the angles C and B. So now we do have a pair of angle and opposite side. We've got that uppercase A is 30 degrees and the opposite side length is 6.2, so we can plug that into the sine rule. So we now use the sine rule. So we can say that sine of B, say, I could start with either B or C. I'm going to start with B. So sine of B over 5, because that's the side opposite B, is equal to sine 30 over 6.2, because that's uppercase and lowercase a. So we arrange a bit. If I take the 5 over to the right hand side, I get sine B equals 5 times, well, sine 30, which is a half, which is 0.5. So 5 times 0.5 over 6.2. Put that into a calculator and I get 0.403. So sine B equals 0.403. So B equals the inverse sine of 0.403, which is 23.77 roughly. And I get that just by plugging it into my calculator. Now, if you watched the previous video, you will know that this isn't necessarily the correct solution, because when we have equations with sine, there are actually often lots of solutions. So there's an infinite number of numbers that would give us sine of them would be 0.403. So we could plug lots of different numbers into sine and get 0.403. So let's just look at the graph of sine to see what we mean. So this is the graph of sine. Now, obviously, the only solutions we care about are ones between 0 and 180 degrees, because remember, B is the angle inside a triangle, and the angles inside a triangle add up to 180, so they all must be less than 180. So let's just restrict this graph to the part between 0 and 180. Now, if we draw a line going through 0.403 on the y-axis, which is roughly here, we see it cuts the graph twice. So our calculator has given us the smallest answer, because that's what calculators do. They'll always just give you the answer closest to 0, which is this one here, so that's 23.77. But we can see that this one over here is also a solution. So sine of whatever this number is, which is much closer to 180, is also 0.403. Now, in the previous video, because we hadn't been given any extra information, we just had to use both these and solve the problem twice. First with the first answer and then again with the second answer. But here, if we look at the question, we are given a very useful bit of information. We're told that B is acute. So B is less than 90 degrees. That's why I use B here instead of C first. So I find B, because I have an extra bit of information on it, then I'll find C at the end. So if B is acute, it's less than 90 degrees. We don't even need to worry about what this other solution is, because it's clearly bigger than 90 degrees. So I take the solution I found and say that is definitely the correct answer. So B is definitely 23.77. But it's worth just checking, like we have here, in case there's more than one solution which matches your criteria. So with sine, cos and tan, often it's the case there are multiple solutions that you have to consider. So we found B, so I can circle that, 23.77. Now let's get the rules back up, and we're going to solve the problem, but now it's really easy. We don't even need the rules. We've used the cosine rule once, we've used the sine rule once, but for the final bit, we know the three angles inside the triangle add up to 180 degrees, and therefore A plus B plus whatever C is 180 degrees, but we know A and B, they are 30 and 23.77, so you add that up, you get 53.77, plus whatever C is 180 degrees. We arrange, we get C equals 180 minus 53.77, which is 126.23 degrees. So we have found C, and hence we have found all the unknowns we were asked to find.